Hi, I'm Marty Peets, and I started C&K Engineering a few years back with the thought of making wireless microphones work better. So what we have are several products that make your wireless microphones, your existing wireless microphone equipment, perform its best. If you read the data sheets, regardless of the manufacturer, it says in small print, their specifications are under ideal conditions. And live performance is not ideal conditions, nor is broadcasting ideal conditions. So we make some equipment that helps your wireless microphones perform more like under ideal conditions. And that is these items here. We have antenna distribution equipment where you can put multiple units off of one pair of antennas. This saves you having to have a lot of antennas on your rig, and you can put your antennas in an ideal mounting position. For example, you can mount them up higher, as we see here. This is our ground plane. That's the factory antenna that we've simply moved up with our ground plane, and it allows you to use that. You can't just take an antenna and stick it on a mic stand. It won't work correctly. So this gives you the same ground plane effect as if it was mounted back on the receiver. This allows you to raise it up above the crowd. You can also put on a lot of people like to use these paddle antennas that they mount on there to give some directional coverage. Out of our distribution system, and we integrate these inside, I have them out for the purpose of this demonstration, we build filters. We have band pass filters and low pass filters, and they filter out undesirable signals. You do not want any signal showing up at your receiver input that you're not trying to pull out of the air. And there's lots of other things that are in the air, and we'll show you those in just a minute. This is our multiple antenna switch. You can hook up multiple sets of antennas, for example, in a condition like a parade or in a sports stadium where you have events happening all around in the stadium, and you can use one set of receivers and route them to multiple antennas through our switching equipment. This also has variable gain amplification, so you can correct for long cable run path loss. Up here shows you we're in the arena at the NAMM show in Anaheim, California in January of 2017, I'm sorry. And you can, when the screen updates, you can see all this different stuff in here. These two signals right here are LTE. This is the band, this is the 700 megahertz band that was taken away in 2010. And there are a lot of people still trying to operate in the 700 megahertz band. It's illegal. Those belong to the broadband wireless carriers. So you're not supposed to use those bands for your equipment. The 600 megahertz band is now being auctioned off also for broadband wireless carriers. So that's soon going to be unavailable. So it makes it more critical to have good quality equipment that can pull out the signals that you want. And I'm going to demonstrate here what our filters and our filter and switching equipment can do to pull out the signals. Now, there are just about 50 feet away from us, this LTE signal is coming. There's multiple small cell LTE signals. I don't know if you can see them up on those spotlight cages. There's 20 LTE antennas. It's called small signal antenna distribution in this arena, and so that's why those signals are so huge. Normally they'd be outside, up on a tower disguised as a palm tree or something. But when I switch in our low pass filter, which is this guy right here, that's routing off. We have one antenna that we've got set up for this demonstration. You can see it up there. That's our disc cone antenna, and it's broadband. It goes from 50 megahertz up to 2.5 gigahertz in one antenna. So it's a super broadband antenna, and we use that for doing site surveys to help people figure out what's going on inside their building. But we're routing the output of that disc cone antenna into our distribution system. We purposely removed the filters so you can see which ones we're using. So I'm going to switch in the low pass filter, and you can see that it knocked. I'll switch it back out so you can see that. You can see that the low pass filter knocked down by almost 20 decibels that upper LTE signal, and about 10 decibels that lower band one. We have other filters that'll go down even lower that knocks this down even farther. So there's the unfiltered spectrum again that you can see. And now the filtered spectrum, where the LTE signals are locked down in amplitude. Now we have a bandpass filter on there, and buried within all of this is one of the low-power digital TV stations out of Los Angeles, which is Mount Wilson's about 45 miles away from here. And we're going to pull that signal out of the mud and get rid of this other stuff that's in there. And there's our little signal right there. Now we still have some interference problems from those LTEs, and we got to wait for the screen to update again, sorry. But you can see if you're trying to operate your wireless microphones, you want to get rid of all this other stuff, because anything that's within the tunable range of your receiver, even if you're not tuned to it, it desensitizes the receiver and it's harder for it to resolve the signal. So that's the type of equipment that we make. We also have some stuff for stage musicians to use. This is our antenna farm. This is a folding system that goes inside a 2RU transit case, and it folds up very compactly, and you can move from the show very quickly. And this folds into the back of the case. We recommend you disconnect the cables, but so we've got 2 receivers and 1 in-ear monitor on here. You can see we've got your in-ear monitor transmitter here and your receiver, your wireless receiver. So if you got your guitar rig or your vocal microphone or whatever, this sits up on the stage behind the artist. This fits in any brand of 2 RU ATA case, regardless of the brand. It's universal to fit. And then of course we've got our T-traps, which keep the in-ear monitor frequency out of the receiver frequency, because you got a transmitter very close to the receiver and you want to notch out those frequencies so that it doesn't stun your receiver input. This is transmitted with a lot of power.